Welcome to Cosmic Compass. Here, we explore the mysteries of space, the hidden stories of planets, and the wonders of the universe beyond our reach. Together, we'll navigate the cosmos, asking questions, uncovering answers, and following the clues that science has revealed. Imagine looking up into the night sky and realizing that not everything we see belongs here. Some objects are just passing through wandering messengers from distant star systems. One of the most famous of these is Oumuamua, a strange interstellar visitor discovered in 2017, but here's the surprise: Oumuamua is not alone. Over the years, astronomers have identified more of these cosmic travelers. They arrive uninvited, slip through our solar system and continue on their way, leaving us with more questions than answers. So what exactly are these interstellar objects? How do we know they came from beyond the sun's domain? And what secrets do they carry with them today? Let's take a journey together to explore Oumuamua and its mysterious companions. Along the way, we'll uncover how they move, where they might come from, and why their presence challenges our understanding of the universe. First, let's step back and understand the bigger picture. Our solar system doesn't end at Neptune or even at Pluto. Beyond Neptune lies the Kuiper Belt, a region filled with icy remnants of planetary formation. But further still, stretching nearly a light year from the Sun, is the vast and invisible Oort cloud. This Oort cloud may contain trillions of comets, frozen wanderers, held in the Sun's distant gravitational embrace. Occasionally, one of these icy bodies is disturbed, nudged inward toward the inner solar system. But what causes this disturbance? The answer lies in the way our solar system moves. The Sun is not fixed in space. It orbits the Milky Way, carrying us along at incredible speed. As we travel, we pass near other stars, and even if they are light years away, their gravity is strong enough to tug at comets in the Oort cloud. Sometimes these gravitational encounters fling comets inward, where we see them blaze across our skies. Other times they fling them outward, ejecting them forever into interstellar space. And if the Oort cloud exists around other stars as well, then countless comets are constantly being traded between stellar systems. That means the galaxy is full of interstellar interlopers bodies that once belonged to other stars, but now roam freely, crossing paths with us from time to time. Some estimates suggest that as many as 10,000 objects per day could be passing near Neptune's orbit. If true, the majority go unnoticed, silent travellers slipping by without ever being detected. In October 2017, astronomers in Hawaii spotted something unusual. At first it was catalogued as a comet named C2017U1, but quickly things became strange. It had no visible coma, no dusty tail. The classification was changed to an asteroid A2017U1, and soon after it received a brand new designation never seen before, 1I2017U1 Oumuamua, where I stood for interstellar. Why was this such a big deal? Because Oumuamua's path through the solar system was unlike anything we had ever observed. Its orbit was hyperbolic, meaning it wasn't bound to the Sun. Instead of circling back, it was moving too fast on a one-way journey out of our cosmic neighbourhood. But that wasn't the only mystery. Its brightness fluctuated dramatically as it spun, suggesting a very unusual shape. Some called it cigar-like long and narrow. Others argued it could just as easily be shaped like a flattened pancake. In truth, telescopes never resolved more than a point of light, so we may never know its exact form. What we do know is that it tumbled chaotically, rather than spinning neatly around a fixed axis. And then came an even bigger puzzle. Oumuamua accelerated as it moved away from the Sun. The effect was tiny, but it was real more than what would be expected for a simple rock. Normally, comets accelerate because sunlight heats their icy surfaces, releasing gas that pushes them forward like a natural rocket. But Oumuamua showed no visible signs of outgassing. No coma, no tail, Astronomers brought in the Spitzer Space Telescope, staring at it for 30 hours in infrared light. If there had been even faint dust or gas, Spitzer would have seen it. But there was nothing. So what caused the acceleration? Some argued it must still be a comet, but with unusual properties, perhaps only releasing gas without dust. Others suggested that its surface had been coated with cosmic dust during millions of years in interstellar space, hiding any volatile material beneath. But then came an even more provocative idea. Oumuamua reflected light much more strongly than typical comets, nearly 10 times shinier. To some, that hinted at a metallic surface. Combined with its unusual shape and unexplained acceleration, a few scientists wondered, could it be artificial? Could it be a probe or debris from an alien civilization? The SETI Institute pointed its radio telescopes toward Oumuamua, listening for signals. Nothing was found, not even the faintest whisper of artificial transmission. Still, the mystery remains unsolved. By now, Oumuamua is far beyond our reach, too distant for any spacecraft to chase. We are left with only the data gathered in those few weeks of observation. Its origin and nature remain one of the most intriguing open questions in astronomy. Just 2 years later, in 2019, another interstellar object was discovered. This one was different. It had a visible coma, a bright tail, and behaved exactly as a comet should. Its name, too, Borisov. Unlike Oumuamua's strange and silent flight, Borisov was almost textbook. It passed beyond the orbit of Mars, glowing faintly but clearly as a comet. Its coma stretched to a size nearly 14 Earths across, yet it never came close enough to be seen with the naked eye. Borisov was similar in size to Oumuamua, about half a kilometre across, but it eventually broke apart after passing the Sun, which is normal for comets of that size. Its composition was unusual, but not unprecedented. Unlike Oumuamua, Borisov's behaviour left little room for speculation. It was a comet, an interstellar traveller, but without the same layers of mystery. In this way, Borisov serves as a useful contrast. Where Oumuamua sparked endless debate, Borisov reassured astronomers that at least some interstellar visitors behave exactly as expected. Not all interstellar objects receive the official I designation. Some, like C1980 E1, began as solar system comets, but were later pushed out by gravitational encounters. In this case, the culprit was Jupiter, whose immense gravity accelerated the comet just enough to give it a hyperbolic escape trajectory. One day, C1980 E1 will leave the solar system and join the galaxy's interstellar population. The reverse can also happen. Instead of being ejected, some interstellar comets may be captured and trapped by Jupiter's gravity. Candidates like Machholz 1 and Hyakutake C1996 B2 may have originated from another star system long ago, but are now permanent residents of ours. How do we know their orbits are highly elliptical and their chemical compositions are different from most comets we've studied? If true, then Jupiter has already done the hard work for us, delivering interstellar objects right into our backyard, waiting to be studied by future missions. Another fascinating candidate is the asteroid 51107 Kaʻepaokaʻawela. Its orbit is highly unusual because it is retrograde. It travels in the opposite direction of most objects in the solar system. Even more intriguingly, it shares a 1-1 orbital resonance with Jupiter, meaning it orbits the Sun in the same time as Jupiter itself. How could such an object exist? One possibility is that it was once a comet from another system, stripped of its volatile material long ago. If captured early in the solar system's history, it could explain why it behaves so differently today. Kaʻepaokaʻawela reminds us that not all interstellar objects come and go. Some may stay locked into orbits that challenge our expectations and expand our sense of what's possible. If interstellar visitors are truly common, then our greatest challenge is simply detecting them in time. Right now, we only spot the largest and brightest, and often too late to study them up close. That's why astronomers are excited about the Vera C. Rubin Observatory, a new telescope designed with a wide field of view. Its mission includes scanning the skies nightly for asteroids, comets, and interstellar interlopers. Once it becomes fully operational, it may reveal far more of these cosmic visitors than we ever imagined. And space agencies are planning ahead as well. One proposal is to keep a spacecraft on standby, ready to launch at short notice. That way, the next time an Oumuamua-like object enters the solar system, we won't just watch it slip away. We'll chase it, study it, and maybe uncover secrets that have eluded us so far. Until then, we can only wait. These travellers remind us that the solar system is not an isolated bubble, but part of a vast galactic network where material is constantly exchanged. Every visitor is a messenger carrying stories from distant stars. So what do you think? Was Oumuamua just a strangely behaving comet, or something entirely different? Could it have been natural debris, or perhaps an ancient artifact from another civilization? The truth is, we don't know. And maybe that's what makes these discoveries so exciting. They challenge us, spark our imagination, and push us to keep searching. What we can be sure of is the next interstellar visitor is already on its way, and when it arrives, we'll be ready. If you enjoyed this journey beyond the solar system, consider subscribing to Cosmic Compass so you won't miss future explorations of the mysteries of space. Until next time, keep looking up and keep wondering.